All right, just a quick follow-up. I didn't mention a couple things that you need to know for your work toward the end of the lesson. If you look at numbers 30 through 38, you'll see f of x equals, and then the expression. I'm on page 586. So for example, it'll say f of x equals x squared plus 11x plus 18. That's essentially just like what you're going to be doing for 20 through 28, which is when they're set to equal 0, which is what I showed you at the end of the last video. So for example, you can just rewrite that x squared plus 11x plus 18, set it to 0, and then go ahead and factor that out, set that to 0, x and x, they're the same, they're both positive. 9 and 2 is what I'm going to use there. So I'll just check it real quick. X squared, 2x plus 9x is 11x plus 18. So I know that's right. And then because it's set to 0, I'm going to set both of these parentheses to 0. And then that'll give me -9, and that will give me -2. So the answer for number 30 will be -9 and -2. Okay, so the same thing, exact same thing, it just is in a different form. And so basically what that means is if you were to plug in x for this form, or excuse me, for this function, it would work out and be a true statement. Same for here. So that's all that means. Didn't want you to be confused by that. And then one final note on numbers 47 through 55. I think I gave you some of those problems. You'll see a couple problems, or actually it's all of them, that look a little different than the first set of problems that I showed you in the beginning of the last video. An example would be number 48. So y squared minus 6yz plus 5z squared. Okay, so I'm doing the same thing. It's just going to be a little different as far as the terms are concerned, but it's the same strategy. Parentheses there. What times what is y squared? That's y. And then both sides are going to be the same. And then they're both going to be negative. So there's that. Problem's almost done already. See how easy this is? Now, instead of it just being a 5, it's a 5z squared. Don't get thrown off by that. And that looks like a z, I know. Okay. Don't get thrown off by that because it'll work out. So just look at the 5. What two numbers will multiply to give me 5, but can also be added or subtracted to give me a -6? Or added to give me 6. We'll just use the 6. 5 and 1. Again, 5 is a prime number, so I can only use 5 and 1. And they're both negative, so it doesn't matter where I put it. So I'll put 5 there and 1 there. Now, if I just do that, that will not give me this polynomial because it's 5. It's not just 5, it's 5z squared. So it's 5z minus 1z because that z times z is z squared. And we know that can just be a z. 1z or -1z is the same as -z. Okay, so let's solve this out and see if it works out. Y times y is y squared. Y times -z is -yz. -5z times y is -5yz. And then -5z times z is +5z squared. Okay, so combine like terms, y squared, there we go, y squared, -yz minus 5z is -6yz, and then plus 5z squared, which is the same thing we get right here. Okay, so same exact strategy. It's just that on numbers 47 through 55, you will have a variable there. Okay, and that's why. And then you'll have that's why you see the y z, because that's the way it checks out. Because instead of just having an x squared, you're having a y and a z, or two different variables. Okay, so that's why that kind of works out like that. So practice those as well. Let me know if you have problems, but just wanted to make sure that you got that as well. Okay, thanks guys.